Recording in progress. Okay, so share screen, PowerPoint, share. Okay, pinning myself over here. So about web assign, malam nanti demonstration. Kalau tak clear, you can ask me later in class, okay? So I'm always available for questions in class. Kalau WhatsApp mungkin lambat sikit. So let's go to your, so we already did this question. I remember you guys doing this in class, which was vector addition, right? Vector addition, and we added three forces A, B, C with different magnitudes and different directions. And what we had to do was, first we wrote the equation, and then we split each vector into its X and Y components. Where is my pen? Excuse me, move here, please. Draw. Okay, so you you resolved the vector into its X and Y component. Macam mana tu? So AX equals to A cosine of theta and AY A sine of theta. So you resolved the vector into its components, X and Y components. And then when you resolved it to the X and Y components, you add them all together, Rx, this is the resultant X. So you add AX plus BX plus CX. Kenapa kena resolve baru boleh tambah? Because you can only add vectors that are in the same axis or in the same line. They have to be parallel. Or in the same axis or opposite direction. Kalau opposite direction, tolak lah. Kalau in the same direction, ke kanan, semua ke kanan, tambah. Kalau seorang ke kiri, tolak. Okay, and then RY, AY, BY, CY. Okay, so some of you made the mistake of just adding the vector like this. Resultant A plus B plus C. Dia cakap A ni 120, dia terus tambah kat sini 120, 96, 150. This is wrong because these vectors have direction. Their direction is like all over the place and you cannot add them just like that. Tak boleh. Unless you're doing graphical method, then boleh lah lukis kan. Lukis tambah tape to tail or tail to tail method. Then you can do that. But for component method, you have to resolve it into its component. Okay, so this is just a recap. I hope you guys are familiar with this already. So saya tak akan ulang, but we are just going to do problems from now on. And then what have we learned apart from that? AX and AY. So we have a vector A, AX equals to A cosine theta, and then AY, A sine theta, and then your Rx is the summation of your x's, vector in the x, and then ry, ay, by, and cy. Okay, can anyone tell me how do you find the resultant vector magnitude? The resultant vector magnitude, what is the equation? Anyone?
R
R
is equals to square root Rx squared plus Ry squared.
Okay, thank you. And anyone else wants to try for the theta, for the angle of the resultant vector? Lupa dah? Baru weekend? Okay.
Inverse tangent equal to Ry over Rx.
Okay, thank you. That is correct. Okay, so now my next question is, what happens if you have you have Rx and Ry. You have Ax and Ay, and you want to find out what is the vector A. How do you do that? How do you do that? Semua tak confident dah. Jawapan yang sama je kot.
Square root
Root
So A equals to square root
ax squared
x squared.
plus ay squared.
yes, and the theta for A
Tangent -1
okay, inverse tangent.
ay over ax.
Ax.
Okay, so don't be confused. Even though we looked at the resultant over here, you can use this for a regular vector. It doesn't have to be addition. Okay, when you have the components of a vector ax and ay, you want to find out what is the vector that these components are coming from. Boleh use the this thing lah, okay, the Pythagoras theorem punya equation to find the magnitude, and also the inverse tangent equation. It doesn't have to be resultant. It can be just a regular vector. It doesn't have to come from addition. Okay, so all vectors can use this equation is the point here. Okay. Okay, moving on. And then we also talked about the angle. Let's talk about the angle a little bit before we move on to the problem. So I told you if I have, this is my x-axis and this is my y-axis, very imbalanced. And then this is my vector A, and this is my vector B. My vector B, tebalnya 30 degrees over here, and this guy is 45 degrees over, about 45, about 50 degrees over here. Okay, so how do I describe my vector A? Let's say the magnitude for vector A is 120 newtons and vector B is 50 newtons. So how do I describe it? What do I write in my answer? Anyone? Let's do vector A first. Okay, vector A. No one wants to try? Come on. Nanti tak tahu.
120
Okay, 120
cos 50.
cos 50. Okay, so sekarang ni soalan saya kan is how do you describe this vector? Bukan its component. How do you describe the vector? So you got the 120 right? 120 Newton. Vector A is 120 Newton. This is, kita nak describe A is 120 Newton with 50 degrees. Okay, so what is this 50 degrees? 50 degrees ni dia boleh refer to anything. So how should I say this 50 degrees?
In respect to x-axis.
With respect to x-axis, yes. That is the answer that I'm looking for. With respect to the x-axis. And we are always referring to the positive x-axis. And when you say with respect to x-axis, you're talking about the positive x-axis, unless you say negative. And then what about B? B is
50
Newton
with 30 with respect to x-axis. With respect to x-axis.
With respect to x-axis. Okay, but the 30 is below the x-axis. So does that change our description here?
Negative 30.
Negative 30, yes. Okay, so something to note. When your angle is below the x-axis, it's minus 30. Unless you want to refer to the positive x-axis, I mean, you want to go from here, boleh, but you have to go all the way here, which is 360 minus 30, that gives you 330. Okay, so I can say or 330 degrees. Oops, 330 degrees. So 330 is the same as minus 30. But 330 degrees is not the same as positive 30. It's only the same with negative 30. Faham tak? Kalau saya cakap positive 30, it needs to start from here. And the angle should be, the vector should be like here in the first quadrant. But your vector is in your fourth quadrant, 1, 2, 3, 4, the fourth quadrant. So when it is in the fourth quadrant, the angle is below the x-axis, so it's a minus 30. Okay, minus 30 or 330 degrees. Okay, so that is how you describe a vector. You describe it by its magnitude first and then its direction. Tak kisahlah atas ke bawah ke, just know whether it's positive or negative and describe it appropriately. And then we also talked about, do I have any questions? Okay, tak ada. Kalau ada boleh interrupt me macam biasa. So there's another thing that I mentioned to you before, which was what if I have a x and y axis. Okay, and then my vector is like this, vector A, and my angle is 35 degrees. What is my AX and what is my AY? Anyone? What is my AX and what is my AY? Dia punya general equation. Sorry, let's just put a value here, 10 Newton. Okay, so what is my AX and what is my AY? What is the equation?
AX
10 Newton
10 Newton, okay.
cos 55.
Cos 35, okay. Any other answers apart from this?
sin 35.
Sin 35, okay. So we have a disagreement here in class. So seorang cakap 10 Newton cosine 35, the other is saying sin 35. Why? Kenapa orang yang cakap sin 35 tu? What is the reason behind this?
Because the angle is not at x-axis.
Because the angle is not at x-axis. So what is the angle at x-axis actually? So 35 plus
55.
55. So the angle here is 55. Okay, so orang yang cakap cosine 35 ni nak tukar jawapan tak?
55.
So it should be 55. Yes, correct. So at AX is equal to 10 Newton cosine 55 if I'm referring over here. So when it resolves, it becomes AX over here. Okay, so this is when I'm using 55 degrees. Now, if this 55 degrees is not there and I only have 35, when I use cosine, I need to use sine 35. When I use sine 35, it gives me AX over here. Walaupun pakai sine. Okay, sine gives me something that is not touching the angle. Cosine gives me something that is touching the angle. Okay, let's try again for AY. What should my AY be? What should my AY be?
10 Newton
10 cos
Cos
cos 35.
35 or
10 Newton
sin
Sin
55.
55. Okay, so I think you got it. So siapa yang touching the angle? For instance, Y is touching 35. So Y, AY gets the cosine. Okay, and AX is not touching 35. So AX gets the sine. AX gets the sine 35. Okay, let me write that properly. A cosine 35. So here AY is touching 35, so dia dapat cosine. AX is not touching 35, so it gets the sine. But if we change this problem, okay, AY and AX to be 55 over here, 55 is touching AX. AX gets the cosine, 55. AY is not touching the angle, he gets the, or she gets the sine, 55. Okay, so just look at the angle. Where does it touch? That person gets the cosine. Okay, I know it's not person, but you get what I mean. Okay, so boleh describe in two different ways. You have to know how to determine whether the equation gets the cosine or it gets the sine. This is something very important. So cosine always gives you something that is touching the angle. Sine gives you something that is not touching the angle or something perpendicular to it. Okay, so let's go on to our problem. Tak ada soalan. We have not done this one yet. Okay, new slide. So Yazid, we haven't done this question yet, right? Belum kan?
No.
Okay.
Belum.
Okay, so Yazid drives from Kuala Lumpur to Kuantan, which is 240 away, in the direction of 30 north of east. Okay, so let's try to draw this. Hopefully I'm doing justice to it. Kecilkan sikit. Oh, no. Silap. Okay. So let's go over the question. Okay, Yazid drives from Kuala Lumpur to Kuantan, which is 240 kilometer away in the direction 30 degrees north of east. So if you guys are not familiar with the compass, or what do you say this? I don't know what it is called. Tapi yang ni north, yang ni east, this is west, and this is south. Okay, so when they said Yazid drives from Kuala Lumpur to Kuantan, which is 240 away, in the direction of 30 degrees north of east, look at this sentence, 30 degrees north of east. You have the off east. When you have off east, your east is your reference point. Your east is the reference point, just like your x-axis. Sebab dia pakai off kat sini ya. North, so it's off east, but going 30 degrees north. You pergi ke arah north sebanyak 30 darjah. Okay, so I shouldn't put north here. So it's going north by 30 degrees off east. Okay. He then continues 200. Let me write that. He is going 240. Then he continues 200 kilometers in the direction of 65 degrees south of east. So off east lagi. Off east is your reference, just like the x-axis. But now he's going 65 degrees south. 65 degrees south. So 65 degrees south. Okay, so this is your second vector. The magnitude is 200 kilometer. And then finally 120 kilometer at 10 degrees west of south. Okay, now my question to you is, how should I draw this? 10 degrees west of south. How should I do it? Which quadrant?
Third quadrant.
Third quadrant.
The third quadrant. So this is 1, 2, 3, third quadrant. Okay, so where should my angle touch? Should I touch the west or the south?
South.
So you should touch the south, and that becomes 10 degrees over here. So let's take a look. So dia cakap 120 km at 10 degrees west of south. Your south is your reference point. Then dia pergi sebanyak 10 darjah towards the west. So betul. The angle should touch the south by, and then the angle is 10 degrees towards the west. Okay. And this is 120 kilometer. That is the magnitude. Okay. Sketch the displacement using tip to tail and tail to tail vectors. Don't worry about that. Using the component method, calculate the distance and direction of Johor Bahru from Kuala Lumpur. So of Johor Bahru from Kuala Lumpur. So Kuala Lumpur is your starting point, right? Your starting, because he did start from Kuala Lumpur, right? This is the starting point and this is the end point. It's asking you to find the resultant vector. Resultant vector in this case is the displacement lah. Displacement from the initial point to the end point where Yazid is driving. Okay, so let's go over the tip to tail and tail to tail method. So kita ada jawapan dah, tapi komponen korang kena buat nanti. So this is the first one. Alah. I need the question. Let's copy it over here. Sekejap. Okay, any question boleh tanya. Tail to tail. Okay, so we already sketched the tail to tail diagram, but the tail to tail diagram cannot give you the answer in terms of resultant vector, because tail to tail diagram only works if you have two vectors to add. Because kalau kita ada A and then we have B, tail to tail vector, and I have to draw a dashed line, right? I have to draw a dashed line that is parallel to the vectors. And it should be also the same length. So this would only work if it's the addition of two vectors. So tail to tail, korang dapat macam ni je lah. There's no resultant associated because you can't calculate using a tail to tail. However, for tip to tail, you can get the resultant. Okay, so let's see. From Kuala Lumpur to Kuantan, which is 240 degrees, 30 degrees north of east. So dia ambil yang ni, this first vector, vector number 1. Okay, this is 30 degrees with respect to the x-axis, and the person who wrote this example drew the vector from here to here. This is the tail, and this is the tip. Okay, because we are using tip to tail, so the next vector, vector number 2 is 200 kilometer in the direction of 65 degrees south of east to Mersing. So this is vector number 2. So vector number 2, tip of number 1 to the tail of number 2. So this is the tail of number 2, and this is the tip. So this is vector number 2. The magnitude is 200. Now look at the angle here. So you have the angle 30 degrees, right? Like that. And this guy is 65 degrees, still with respect to the x-axis. Even though you're using tip to tail, the angle, you have to maintain it. Angle kat sini 65 degrees with respect to the x-axis. This is also 65 degrees, like this. Okay. And then this is your second vector. The third vector, finally, 120 kilometer at 10 degrees west of south. So this is 120 for the third vector. So we connect the third vector tip to tail, tip of the second vector to the tail of the third vector, and still you are maintaining the angle. Angle kita tulis pada y-axis tadi. Y-axis tapi ke bawah. So sama juga, kena sama. Kalau lain, korang punya ni tak sama, salah. Okay, so if you are more comfortable drawing in tail to tail, and you struggle with tip to tail, you can do the tail to tail diagram first and transfer your arrows in the tip to tail if your tail to tail helps you. Okay, kalau dah comfortable dengan tip to tail terus, boleh buat terus. Okay, so this is 10 degrees and this is 120. So make sure you are using a proper scale. So in this case, if I were to draw this on paper, do I write the 200 feet? Do I use a ruler to put 240? Boleh kan? Tak muat kan? So you use a scale. So for example, let's say 20 kilometer is 1 centimeter. So in this case, you only have to draw 12 centimeter. So 240 kilometer is 12 centimeter. This is your scale. Scale to draw on paper. Kena sama untuk semua. So 240 divided by 20, you get 12 centimeter. 200 kilometer, you draw 10 centimeter. And then for the 120, you draw 6 centimeter. Okay, 6. Okay, so on paper, using your ruler, you will have to draw a line that is 12 centimeter in length over here, and then 10 centimeter in length over here, and 6 centimeter in length over here. And then your resultant is from the initial to the end. I think we already know this. Okay, and then you measure using your ruler. I don't know what you will measure. Let's say you measure 15 lah, 15 centimeter from the initial to the end. So what is your final answer? What is your final answer?
300.
Berapa?
300 kilometer.
300. 15 centimeter is 300 kilometers. So this is your magnitude. Okay, so using your protractor, measure with respect to the x-axis. So this is your angle. So the answer is 300 kilometer. Let's say this is 25 degrees minus 25 degrees with respect to the x-axis. Okay, so that is your final answer. Boleh? Sorry, tapi dalam soalan ni dia pakai north, east, west semua tu kan? So you have to use terms tu lah. So in this case, it is 25 degrees. Let's say it's 25 lah. We don't know what the answer is yet because kita tak buat component method. Let's say this is 25 degrees. So how should I describe this in east, north, west, south? Anyone wants to try? Okay, so this is
25 south of
25 south of east.
south of east. Okay, betul. 25 degrees south of east. Dia cakap south of east. So reference point is east. This is east, betul. This is east. And then going down by 25 degrees. Going down south by 25 degrees. So betul, jawapan dia 25 degrees south of east. So that is how you describe it. If they are using south, east, west, north, semua itulah. If they are not using this, just describe it in angle. Macam biasa yang kita belajar with respect to the x-axis. Okay, so now let's do the component method. Component method akan give us the exact answer, not using graphical method. Okay, so now I'm going to assign people to do this as usual. Okay, so let's see. I want, nama sekejap. Oh, hari ni korang senyap tak ada soalan macam biasa. So can I get Aliman Zafran to resolve this vector. Macam nak cakap. Aliman to resolve this guy in x and y. So this is Aliman. Panggil Aliman ke Zafran? Saya lupa lah. Okay, and then Alisa. Oh, hari ni A saja. Sekejap, sorry. Alisa tak payah lagi. Kita buat nama lain bawah pula. Selalu saya ambil yang atas-atas je. Okay, Sharifah. Saya jarang panggil Sharifah. So Sharifah resolve 200 ni. Sharifah. Okay, resolve resolve into x and y. Sharifah. Okay. And then Rachel to do 120 resolve. Okay, Rachel. And then Rachel. Tak cukup tempat tulis. Rachel. Oh, sorry Rachel. Tulisan buruk. And then, oops. Khalida. Khalida to find out what is the Rx. So Khalida. Okay, the rest of you jangan seronok sangat. Saya akan panggil juga nanti. And then Najla RY. Okay, so kita banyak sangat the girls. Let's find one boy. Ikri macam belum Okay, kejap. Faris lah, Faris. Faris to find me the R and the theta. Okay. Okay, so I'm gonna give you guys 7 minutes to do that. So let's talk back at 11:45. The rest of you, please try this example 2. Okay, to nak tahulah understanding korang dah sampai ke belum. Nanti nak buat assignment susah kan? So make sure you understand this problem. If you have question, you can ask me. Okay, 7 minutes from now. Boleh discuss no problem. Jap. I have one chat here. Doctor, I have stomach ache. Okay, no problem. Oh, sorry. Okay. This is the question. Oh, ada lagi chat. Doktor, if nak describe yang tadi tu with respect to the x-axis, the angle would be minus 25 degrees. Betul. The answer would be minus 25 degrees sebab dia kat bawah x-axis. Betul. You're right, Raihana. Oh, ada lagi soalan. Okay. Doktor, nilai magnitude tu sebenarnya dalam unit Newton atau kilometer? Atau rujuk pada soalan? Okay. Nilai magnitude ni bergantung kepada soalan. In this case, our magnitude is kilometer. Okay. Bergantung kepada soalan. Oh, bagus kok soalan-soalan korang ni. Keep it coming. Okay. When you ask me questions, it helps me to macam mana cakap? It allows me to understand what you guys don't understand. So saya boleh explain. Sebab saya tak tahu apa yang korang tak tahu. Kan? Sebab kita punya level of knowledge different. So when you ask me question, it helps me a lot actually. So thank you so much. Is it time yet? Oh, 4 minutes to go. Let me write down the time. Did I? Oh, it's already here. Doctor, the second and third vector, the degree will be in negative, right? The third and the second vector. Second, yes. Third, you can't use 10 because it's not referring to the x-axis. But okay, that's a good question. So, nanti kita akan discuss pasal ni. Doktor, boleh kan kalau kita dah dapat x, kita gunakan tangent untuk dapatkan y? Saya tadi nak bayangkan je. Boleh kot, tak tahulah. Boleh rasanya. Tapi saya tak nak bayangkan sekarang ni. Nanti korang tunjuk macam mana nak buat. Alisa nanti boleh tunjukkan kalau nak try. Tengok jawapan sama ke tak. But I think boleh. Sebab it's just Pythagoras theorem. Jawapan dia sama je sebenarnya. Okay, that's good. So, boleh pakai. Like I said, just use whatever approach that makes sense. Physics ni is not restricted. As long as it goes back to the answer, it's fine. So is it time yet? Oh, it is. Okay, we are 1 minute over the deadline. Okay, so I want Aliman Zafran to help me find, to help me resolve. So let's use blue color today. Okay, so Aliman, do you want to give me the answer? How did you find it?
Yes, doctor. For the x component, I use 240 cos 30 degree.
Sekejap kita label lah ni A vector, this is B vector and C vector. Okay, so AX kita panggil ni AX. Lupa pula nak label untuk korang. Okay, so AX is 240. Okay, cosine berapa tadi?
30 degree.
30 degrees, okay. And the answer is?
207.85.
Okay, what is the units here?
Kilometer.
Kilometer, okay. What is your AY?
For AY, I put 240 sine 30 degrees.
Okay, and your answer?
120 kilometer.
Alright, thank you. Oh. Okay, so tengok jawapan Aliman ni. So Aliman, panggil apa? Zafran ke Aliman? Saya lupa lah, sorry.
Zafran, doctor.
Zafran, okay. So Zafran resolve this vector, right? And remember, if you are resolving a vector, the vector should be in between the components, right? So kalau saya nak resolve, saya akan dapat something like this. So AY and AX. Okay, so my AX is to the right, positive value, AY is up. So AY is positive as well. So dua-dua dapat positive as ni, which is correct. Okay. And another thing is your AX plus squared plus AY squared will give you what? What does it give you? What is the answer here?
Magnitude.
Okay, what is the magnitude here?
A.
Dapat berapa?
40.
240. Okay, you get back the answer. When you use the components and you find out the magnitude, the answer is actually the magnitude of the vector that you tried to resolve. Okay, so semua benda ni is in a cycle. Kalau rasa jawapan kat sini salah, memang salah lah somewhere. So that is how you can double check your answer. Okay, so but we don't need it here. I'm just telling you. Okay, so that is the result for vector, the components for vector A. And then next is Sharifah for vector B.
Yes. So for BX, it's 200 times cos 295.
Cosine to berapa?
295.
295.
95.
Okay.
So the answer is going to be 84.52 kilometer.
4.5 kilometer. Okay. So preferably two decimal places. So what is the two decimal place punya answer?
84.52.
Two decimal 52. Okay. Start dengar, sorry. Okay, BY
200 times sine 295.
okay, sine 295. Okay, the answer is
Negative 181.26 kilometer.
181.
181.26 kilometer.
26 kilometer. Okay, thank you Sharifah. Okay, Sharifah did a good job here sebab dia terus cari daripada sini sampailah ke sini. So dia tak payah risau pasal negative, positive. So because she knows that she's going to get the right answer if she uses with respect to the positive x-axis. But if Sharifah uses 65 instead of 295, her answer would not give her a positive here. The answer will not be a negative over here. Dia akan dapat positive. So with that said, you have to know that your BX is going to the right, which is a positive, and your BY is going downward, which is a negative. Okay, so kalau kita pakai 65, 65 over here, kita akan dapat positive. 65 sine 65 times 200, you get 181.26, but the answer is a positive. When you get a positive, that is not correct lah. So how can you use 65 and get the right answer? You have to draw your components beforehand. Draw siap-siap macam saya ni. Lepas tu tengok, oh BY ke bawah. Walaupun jawapan dia positif, saya kena tambah negatif dalam jawapan saya. Faham tak? I hope that makes sense to you. Okay, so Sharifah did a good job of terus pakai 295. Boleh pakai 65 tapi kena tahu BY going downwards. Boleh. Boleh dua-dua boleh. Dua-dua boleh but you have to know lah. Cuma ni lagi senang. Okay, the 295 is easier. Okay, so oops. Ada tak soalan about using 65 versus 295? Did everyone understand that?
Yes.
Yes.
Alright, so next moving on to the next one. Sekejap saya nak tulis kat mana Khalida dengan Najla ni. Khalida, Najla. And then Faris. So CX and CY, that is Rachel.
I put 120 cos 260.
Okay.
I get negative 20.84.
Negative 20.84. And the units is?
The unit km.
Yeah. Okay. What about CY?
120 sin 260.
Okay.
I get 118.18.
0.18 kilometer. Okay. You got positive ke negative kat sini?
Positive.
Oh, you got positive. Okay. Okay, so let's check this one. So Rachel is doing C. Thank you, Rachel. Thank you so much. Rachel is doing C, and C is this guy, right? C is the vector going down here. So if I were to resolve it, this is my CX, and this is my CY. So I should be getting a negative X component and a negative Y component. Tapi Rachel dapat positif. Apa Betul ke sine 260? Sekejap. 180 plus 80. 180 plus 80 is 260, betul. 2 sine 260 is a minus. So it's
Sorry doktor, saya tak nampak negatif.
okay. So the answer is the negative Buat saya panik je. Okay Rachel. So negative 118.18. Okay. So using 260 patutnya dapat jawapan terus negatif positif yang tepat. Okay. So kena tengok betul-betul kat kalkulator. Jangan tersilap tengok. Okay. So what if let's go to the other way yang let's say kita nak pakai 10 degrees lah. Let's say you are lazy to calculate the 260 and you want to use the 10 degrees. So what will happen, right? So saya kena kemaskan sikit sebab saya pening kepala tengok benda lah ni. Just remove everything. Okay. So this is the angle. This is the angle. Okay. Remove these two. Okay, so I have I want to use, okay, yang ni straightforward lah, kita terus pakai cosine 30. What about this guy, cosine 65, we already discussed it. Sharifah used 295, I can also use 65 and that would give me a positive answer for this guy. But we have to know that when we resolve it, this guy would give me bx over here, which is a positive, and a by that is a negative. So kena letak sendiri the negative and the positive sign if you are using 65 degrees. Kena tahu sendiri Okay, so what if we are using this 10 degrees? Because we are lazy. Why not, right? Sometimes we are lazy. So if I'm lazy, I need to resolve. I need to know that, okay, so the by goes down here. Sorry, that's a cy. And the cx is over here. I have to know that the cy is going down and the cx is going to the left. Benda ni basic kena tahu yang ni. Yang ni tak boleh tak tahu. Yang ni kena tahu. So your vector is always in between the components. Kena tahu yang ni. Okay, so with that said, I want to use the 10 degrees, right? So 10 degrees, what is touching the angle here is a cy. So cy gets the, what does it get? Does it get a cosine or a sine? Cosine, right? So cosine C, cosine 10 degrees Celsius, 10 degrees Celsius, 10 degrees. So C is berapa tadi? 120.
120.
Okay. And I know that this guy is going down. So whatever answer I get, I will get a positive. But yang sebetulnya saya kena letak negatif tu sendiri. So 120 times with a cosine 10 gives me 118.18. 118.18 without the negative sign. But looking at this diagram, oh, I know it's going down. So I put in the negative myself. Boleh? Boleh And then cy, sama juga 120 sine 10 degrees. The angle is not touching, so it gets a sine. The answer should give me, oh sorry, saya dapat, this is cy. I was saying cy tadi. Okay, so 120 sine 10, so I get the 20.84. Okay, so I kira pakai calculator, sine 10 times 120 gives me a positive answer of 20.84. There's no negative sign. I look at this diagram, I know that it should be a negative. Put that here. Boleh. Ni cara orang malas. Saya selalu pakai cara orang malas. You can be malas or rajin, jawapan dia tetap akan sama. Okay? As long as you know how to use it correctly. Okay, so that is the answer. Okay, next one. Khalida. What is the Rx here?
Rx equal to 207.85 plus 84.52 minus 20.84 equal to 271.53.
What's the units here?
km.
Okay, thank you. And what about the Ry, Najla? Okay. Is Najla there?
Ry.
Okay.
Yes. Ry equal to 120
minus
Minus
181.26 minus 118.18
okay.
equal to negative 179.44
4, okay.
kilometer.
Kilometer. Thank you. Najla nak tanya. So I get an Rx that is positive and an Ry that is negative. Which quadrant
Yes.
will my vector be? Will my resultant vector be? Which quadrant? Quadrant 1, 2, 3, 4.
Wait. What's there? 4.
Quadrant 4. Okay. Thank you. Betul. So Rx positive right here and Ry is a negative. So that gives me a vector in quadrant 4. Thank you, Najla. So we get the R over here. Just that we don't know what the angle is yet. So Faris will tell us what is the magnitude and also what is the angle here. Okay, Faris, over to you. What's the answer for R?
For R, square root
Okay, R is square root
271.53
okay,
squared plus and minus 179.44 squared.
179.44. Okay.
And the answer is 325.46.
345.
325.46
20.46. 20, sorry, 20, 20,
kilometer.
okay, kilometer betul. Okay, what's the angle?
The angle is inverse tan 179.44 divide by 271.53
Okay,
and I get negative 33.46.
negative 33.46. So your calculation ni memang tak ada negatif kan kat sini? Ke ada negatif?
Ada
Ada.
negative
Okay. Okay, so thank you. So dia dapat jawapan, Faris dapat jawapan negative 33.46. Negative 33 refers to down here. So kalau Faris tak letak negative sign tu, let's see what happens. 179.44 divided by 271.53, that gives me 0.66. Inverse tangent of that will give me 33.45 positive. Kalau Faris tak letak negatif kat sini, it's a positive, the answer will be positive and you will think that it is over here. You will think. If you did not draw the Rx and the Ry that we did earlier. So that is something tricky lah. So this is why I like to draw the Rx to the, kita tengok sini positive, Rx to the right. Ry is negative, Ry ke bawah. And I immediately know that my resultant vector should be in the fourth quadrant. So if my answer is a positive, that will give me an answer in the first quadrant, which is incorrect. So then when I see it's incorrect, I look back at it. Okay, so I'm missing the negative sign here. So I should need to put in the negative. So kenapa saya punya peluang? Okay, so I get a negative sign over here, which gives me an angle below the x-axis and everything makes sense. Okay, so any questions about this one? Everyone's okay? Doctor,
Okay.
if
Okay.
I use, okay, that's good. Kalau soalan boleh tanya, Doctor, if I use the angle 80 degrees and still got the same answer, but need to add on the minus, still correct. 80 degrees untuk apa Rai, Hana, can you tell me what 80 degrees is for?
Vector C.
Oh, vector C. Oh, sebab dia 10 degrees 10 degrees like this. Oh, so you want to use the 80, boleh? So you just add the minus sign kemudian, boleh juga.
Okay, thank you.
So Rai wants to use 80 degrees instead of 10. So when she uses 80 degrees, the CX becomes C cosine 80 and the CY becomes C sine 80 sebab yang angle yang touching is X. 80 degrees is touching the X angle, the X axis. So the X axis gets the cosine. Kalau kita pakai 10 degrees tadi terbalik kan? Kita punya CX pakai sine. Boleh juga, boleh. And then tambah the negative sign sendiri. Boleh, semua boleh. Dengan jawapan sama. Asalkan faham buat apa So the key here is to understand what you're doing. Okay, so I think everyone got it. Kalau rasa susah lagi, boleh try do the examples. Dalam buku ada problem. I think it's similar problems. And then you can try the web assign later on when you've got your login ID semua tu Okay, so with that said, let's take a 5-minute break and then we will continue with multiplication and division by scalar. 5-minute break. So that is 12:10. 12:10, 5-minute break. Go to the toilet or whatever. Oops. Saya pun nak break. Tekak saya kejap. So 12:10 Let's start 12:10. One, two, three, 25 plus 13. So we have 38 in class. We have 38 in class. Okay. Doktor macam mana 10 darjah boleh jadi 260 darjah untuk vektor C? Is it not? 180 plus 80. Betul kan? 260. Okay, nanti kita cakap sama. One minute to go. I don't know if I told you guys that my calculator I pakai daripada my high school. Wait, where is it? Oh no, I lost it. Okay, tak tahulah. Betul I pakai since my high school. So the battery is like, and I never changed the battery. So it's dying. And selama ni saya salah tekan calculator kan. Whenever I do calculations, it's always wrong. And I didn't know why, but apparently it's because of the battery. So when I change to a new one, I'm no longer making mistakes. So today, rupa-rupanya it's the calculator, it's not me. I thought it was me. I thought I'm just clumsy. That was just like a fun fact. Okay, it's 12:10. So let's continue. Okay, so let's continue with our next subtopic, which is the last one, thank God, multiplying or dividing by a scalar. And then we have like multiplying and dividing by a vector as well. So those are the two subtopics yang terakhir untuk kita. Okay, am I still recording? Yes. Okay, so the result, oh sorry, I had a question early on from Rashida. What was it? Doktor, macam mana 10 darjah boleh jadi 260 for the vector C? So earlier on we had the vector C. Kenapa saya ingat semacam? We had, this is our x and y, right? And my vector C was over here. And it was 10 degrees. So this is vector C. So this guy is 90. This guy is 90 and this guy is 90, right? So 90 plus 90 is 180. 180 plus 80 gives me 260 degrees. Okay, so that's how you get the 260. 90 plus 90 plus 80 or 180 plus 80. Or if you like to subtract 270, this whole thing is 270 minus 10. Boleh juga. Okay. I hope I answered that question. Kalau confused lagi, kena revise on orang panggil coordinate system. Bukan. Cartesian coordinate, bukan. I don't know what it's called. But the whole circle is 360 degrees. One quadrant is 90 degrees. Two quadrant is 180. Three quadrant is 270. Okay, so your addition and subtraction comes from there. Okay. All right, so multiplying or dividing by a scalar. So the result of a multiplication or division is a vector. For example, I have a small r here and I want to make my small r the same value, the same vector as my capital R. So I have a small r, this is my big R, this big arrow is big R, and I want to equate my small r into my big R. So I can multiply it with a scalar quantity. This is a scalar quantity because it's just a value, it's just a number. So multiplying 6 times with vector R gives me 6R or R big R. Okay, so when you multiply a scalar with a vector, it's just multiplication, nothing happens, nothing special happens to it. Okay, sama macam multiplication biasa. And if you might multiply it with a -2, you get the opposite direction. So -1 times R, instead of going to the right, it now becomes to the left. So multiplying with a negative scalar gets you an opposite direction, but it's still a vector, okay? Scalar with vector, you get vector. Scalar with vector, you get minus vector, okay? And then division pun boleh sama juga. So you have your big R divided by -2. -2 is a scalar quantity. It's just a magnitude. You get equals to 3 minus R. Okay, so it's just the same as multiplication and division macam biasa. Okay, just that when you multiply it, you still get a vector. Vector with scalar, you get vector. Okay, so nothing complicated about it. Macam biasa je. And then these are the examples of multiplication between scalar and vector. For example, we have our f equals to ma. A is a vector because its acceleration has a direction associated with it, and m is mass. Does mass have direction? No, mass does not have direction. Weight has direction. Weight is going down due to gravity, but mass is basically your atoms, right? The atoms that make up your body or the atoms that make up an object. So that is mass. Mass does not have a direction. It is simply being there. So mass is a scalar quantity because there's no direction, okay, associated with mass. So if I say my mass is 10 kilogram, that's it. It's just 10 kilogram. There's no up and down, left or right. So it's just 10 kilograms, right? So acceleration is a vector because it has direction. 10 meter per second squared to the right, 10 meter per second squared going up. Boleh. There's the direction. So scalar with vector gives you vector. Force also has a direction. There's magnitude and direction. And then we also have elastic force. Force memang vector lah, okay? K, where K is the spring constant. K is the spring constant and X is the displacement vector. Okay, displacement vector multiplied with a scalar quantity of the spring constant gives me a vector force. Spring constant. Okay, so these are just examples lah of scalar with vector. This is displacement. Oh, ada tulis kat situ. Okay, and then we have electrostatic force. K is a constant. And then the final answer is also a vector. So multiplication of scalar with vectors gives me vector. And then centripetal force, sama juga. R is a scalar quantity. Velocity is a vector. This is a vector. And this is scalar. And this is scalar. Okay, I should do that. Yeah. What different colors. Okay, so this is vector. Mana vector? This is vector. This is vector. And any vector dia. This is vector. Get vector. Get a vector. Get a vector. Okay. Ni scalar. Scalar. This is scalar. Scalar. This is also mana scalar? Scalar. Okay, so you don't have to be panicking about this equation. Kita akan belajar kemudian. Just have to know what is the takeaway from this slide. Anything that is multiplied, any vector that is multiplied with a scalar, you will get a vector. This is the takeaway from this slide. You don't have to panic about the equations yet. Okay, not yet. Belum belajar lagi. Okay, moving on to the example of this. So elastic force of a spring is determined by the Hooke's law given by F equals to minus kx. This is elastic force. Okay, elastic force of a spring. Elastic. This is the force, but elastic force. It refers to the force of a spring. So here you can see that there's a minus sign over here, which means that if my force is going up, my x has to go down. And if my F is going down, my X has to go up because of this minus sign. Remember, if I have a minus sign, the vector needs to be in the opposite direction. So F dengan X kena opposite direction. So let's see. So my spring is going down, it's extending down, where X is the extension of the spring and K is the spring constant. X is the extension of the spring and K is the spring constant. When a load is attached to a vertical spring, so kita ada load kat sini, this is the mass, attached to a spring. Mula-mula spring tu dekat sini. Mula-mula dia dekat sini. Ada mass kat sini. Sorry. Dia belum letak mass lagi. So, mula-mula spring tu dekat sini. When I put mass on the spring, okay, letak kat sini, dia jadi berat. So, dia ke bawah. So, bila dia ke bawah, dia memanjang. So, the spring extends by X. Memanjang sebanyak X. Okay. So, dia berubah panjang itu sebanyak X. So, the length of the spring increases from 10 to 12. The length increases from 10 to 12. So, X, this is the final length, which is 12 centimeter. The initial length is 10. So these are the info that we have. Calculate the elastic force on the load. So it's asking what is F? If the spring constant is, if K is 150 Newton per meter. Okay, so these are the values that they have given and they are asking us to find F over here. Okay, dia dah kasih equation dah. Okay, so let's use this equation. So F equals to minus K 150 Newton per meter, and then it's asking for X. So in this case, my X ataupun sebenarnya delta X lah. So delta X is the change in the length of the spring. The change in the length of the spring is given by X final minus X initial. So when you have this symbol triangle ni, it means the change. It means the change. So this triangle means the change. And the change is always final minus initial. Oops. Final minus initial. Always tak ada yang initial minus final dulu, tak ada. Final minus initial. Kalau ada lecturer yang cakap terbalik pada sini, dia salah. This is physics, physics punya convention. The change is always final minus initial. Okay, so delta X is equal to delta final, sorry, X final minus X initial. So this will give me 12 minus 10. And this is 2 centimeter. Okay, so look at this constant, spring constant ni dikasih 150 Newton. This is SI and this is also SI. So if I multiply 2 centimeter here, this is not an SI unit. So dia tak boleh cancel out. So what should I do here is I need to convert it to meter. So 2 centimeter is 0.02 meter. Baru I can use it in my equation and everything will cancel out. Okay, if I use centimeter boleh, tapi dia tak boleh cancel out lah, dia tinggal kat situ. Dia tertinggal lah. Dia jadi Lone Ranger kat situ. Okay, so I have my meter over here, I can cancel it out. My favorite thing in the world is doing that. Sebab menyenangkan hidup kita semua. 150 times 0.02 is equal to 3 minus 3. What unit is left? What is the unit left here?
Newton.
Newton. Because I already cancelled out my meter. Okay, so the answer is minus 3 Newton. So let's look back at this one. So I said going down is 12, sorry, going down, the X is going down and I put it as positive. Walaupun dia going down. So when I say going down is positive, going up is negative. So my force is going up. Okay, walaupun tulis negatif kat sini, it's going up. Sebab I said plus 2 is going up. Sorry, plus 2 positive is going down. Okay, so this is my way of defining dalam soalan ni. So the way that, another way that I can do this is, ni satu cara kan. The other way to do this is, I want to say going down is negative. I want to say going down is negative and going up is positive. So if going down is negative, this is 12, minus 12, and this is minus 10. Minus 12, minus 10 gives me a positive 10. This gives me, sorry, this is minus. So this gives me negative 2 or negative 0.02. Okay, so this becomes negative 0.02 meter and this will give me a positive answer. So this gives me going up is positive. Okay. So what happened? Let me do a recap now. So what just happened? In the first way I defined in the first time that I talked about this problem, I said 12 centimeter was a positive, 10 centimeter was a negative. 10 centimeter was a positive. Duduk positif. Saya cakap going down is a positive. 12 dengan 10 ni dua-dua saya letak positif, which meant that I said going down is a positive. Okay, so I said going down is a positive, going up is a negative. Boleh sebab ni seperti saya lah, ni soalan saya kan. So saya cakap going down positive, going up negative. So when I said going down is positive, this will give me positive, and I put here positive. So my final answer is negative. But this negative does not mean going down, because earlier on I defined going down is positive, going up is negative. So apa-apa yang negatif bermaksud positif, bermaksud menaik ke atas. Okay, so this is defined by you. If this confuses you, please stick to the convention, which is convention adalah going up positive and going down is negative. Ini cara convention, cara yang common, semua orang boleh pakai, semua orang boleh faham. Tapi kalau rasa seronok nak pakai terbalik, boleh. Jawapan dia akan tetap betul. Okay? I hope I didn't confuse you. Tapi benda ni penting kan, sebab kita akan tukar-tukar, kita akan flip kita punya direction. So it's important for you to understand that the direction is actually defined by you. You want to say going to the right is negative, you can. Boleh. Okay, but the convention is to the right is positive. Macam tu je lah. Alright, so multiply a vector quantity with another vector quantity. Okay, so we have two types of multiplication. One is called dot product and the other is called cross product. Dot product, the symbol is a dot. Cross product, the symbol is an X. So here you have vector F dot product with S, displacement. Vector F dot product with S. So force dot product with displacement. So expanding the dot product is actually Fs cosine theta. Fs cosine theta. And expanding the cross product is Rf. So this is R vector and this is F vector. Expanding the cross, which means that you are removing the X, it becomes sine theta. What is the theta? The theta is the angle between the two vectors. So if this is F and this is S, the angle is 30, you put in 30 over here. Okay, and then if this guy is R vector and this is F vector, the angle is 120 over here. So you put in 120. The angle between the vectors. This is not with respect to X. This is not with respect to Y. It is with respect to each other. So you have two vectors. What is the angle between them? That is the angle over here. Tak ada kaitan dengan x-axis, tak ada kaitan dengan y-axis. Okay, angle between them. So a dot product will give you a scalar quantity, while a cross product will give you a vector quantity. Okay, so dot product, symbol dia dot, expanding cosine, dapat scalar quantity. So cross product, symbol dia x, expanding is sine, you get a vector quantity. How do you know it's a vector? There's a topi kat atas dia. So let's take a look on how to use this. Okay, so dot product. Why do we get a scalar quantity and why don't we get a vector instead? So when we are talking about dot product, we are talking about cosine, A, B, cosine theta. And remember, the guy that is touching the angle gets the cosine. So what you're doing is you are finding the component of B that is parallel to A. In this case, your A is your x-axis, and you want to find what is the component of B at the x-axis, right? So this becomes B cosine theta, and this is A. Okay, let me repeat myself. I know it's a little bit confusing. So when you have a when you have two vectors and you are finding the dot product, what you are actually doing is finding one vector in terms of A. What you are doing is finding one vector in terms of the other vector. Okay, so I have B vector over here. I want to find out what is the component in the same axis as A. I want to find out what is the component in the same axis as A. So to find the component in the same axis as A, it becomes B cosine theta. Okay, so now my multiplication between these two vectors is AB cosine theta. Okay, they are in the same direction and I just multiply them and the direction disappears because everything is in the same axis. The direction is no longer relevant. Okay. Okay, so what if we switch around the vector B dot A? The answer will still be the same because now I am finding A in terms of B. So let's see. So this is A. Sorry, betul lah A. This is B. So if my equation becomes B dot A and I expand it, it becomes BA, sorry, this is theta, BA cosine theta. And what happens here is the vector B remains and I am finding what is my A component in the same axis as B. So this becomes A cosine theta. And then it becomes BA cosine theta lah. Okay. So it is the same as if we are talking about finding the BX, finding the BY. When we talk about BX, we are saying B cosine theta. When in reality, we are resolving the X, the BX in terms of X-axis, right? Anggap yang ni X-axis. So sebenarnya sama je. I am resolving in terms of X-axis. I am resolving in terms of Y-axis. So this is BY, this is BX. But in this case, we don't have the X-axis, but we have an A vector. This is A vector. I want to resolve it in terms of A vector. So it becomes B cosine theta. But the angle is between the B and the A instead of X-axis. Okay. So dia sama macam X-axis, cuma anggap sekarang ni axis baru kita adalah A. So with that said, when we multiply everything in the same axis, the direction disappears because it's no longer relevant. Kita semua tahu dia satu axis je. So apa nak kisah pasal direction kan? Kita tahu dia sama direction semua. Tu jawapan dia akan sama direction. Okay, so for a cross product, you are finding the perpendicular component. Okay, remember when we resolved BY, it was B sine theta. And this is B. And this is the x-axis. And this is the y-axis. Okay, so let's see, this is A. You are finding the perpendicular component. The perpendicular component. So you are finding something over here. So what do you get? You get a B sine theta and A. So this is 90 degrees. Tadi kita nak semua sama axis. Sekarang kita nak dorang 90 degrees. Cross product. Nama dia cross kan. So 90 degrees. Nampak tak sini? 90 degrees. Dia nak semua orang 90 degrees. So bila A cross product with B, okay, I want this guy to be 90 degrees to A. That is what it's saying. So A darab dengan B sin theta. So what do you get? You get A over here and you get a B that is 90 degrees to A. Kalau A macam ni, dapat B macam ni lah. Asalkan 90 degrees. Cross product, always 90 degrees. And you get AB sin theta. Okay. So what is the final answer? AB sin theta. The final answer is using your right hand rule. You will get something that is, I don't want to make you guys panic, but this is the reality. So B sin theta with A, the cross product gives me something in the Z. Let's say this is resultant. Okay, so this is 90 degrees, 90 degrees. So the answer to this is a vector that is 90 degrees to B and also 90 degrees to A. So kalau yang ni dekat Y axis, yang ni dekat X axis, this guy is in the Z axis. Okay, so the answer is totally perpendicular to both vectors. So this is the answer for cross product to resultant vector dia punya direction. Dari segi magnitude, you use this equation. Okay, let's do a recap because I know this is like confusing to you because it's new. But it's nothing to worry about sebenarnya. Okay je. Okay, so let's do a recap. Kalau ada soalan, boleh tanya. Okay, saya tak ada soalan. I think everyone's sleepy right now. So what we're talking about dot product and also cross. Okay, so what is the final answer to dot product? The resultant is, sorry, the answer is not called a resultant because it's not a vector. So the final answer is a scalar. There's no direction associated to a dot product punya answer. The final answer here is a vector. Okay. And then for a dot product, the symbol is a dot. For cross product, the symbol is an X. Okay. To expand this becomes cosine theta, where theta is the angle between the two vectors. To expand this becomes sine theta. Okay, so A dot B gives me A B cosine theta. And then A cross B, whoopsie, A cross B gives me AB sine theta. What does this give me? This gives me the magnitude. And this also gives me the magnitude. Okay, so since the final answer for a dot product is a scalar, so this is my final answer lah. There's no direction, so this is the answer that I'm looking for, just the magnitude. But for vectors, the answer will be the direction of the resultant, the direction of resultant R, let's say this is R, okay, saya malas nak tulis, resultant R is 90 degrees to vector A and B sine theta. Okay, so the direction of R is 90 degrees to vector A and B sine theta. Alright. So ada tak soalan yang kita boleh buat? Let's see. Okay, so these are examples of dot product of vectors. So work done by force dot product with displacement, you get work done. Magnetic flux, magnetic field times with area. Area kita tak belajar lagi pasal direction dia, nanti kita akan belajar. So you get a magnetic flux, which is a scalar. You're only concerned about the magnitude. There's no direction associated. Then we have torque. Torque is arm length times force, so vector, and then you have the QV times magnetic field. You get the magnetic force, angular momentum. Nanti kita akan belajar semua ni, don't worry. Basically, what you need to know is cross product gives you a vector, dot product gives you a scalar. Okay. So this is an example of a dot product. The work done on an object by force F that moves with displacement S. So it's saying that this object moves to the right. It moves to the right by displacement S. So the final position is this guy lah. Okay. Gambar dash ni. Okay, and then it moves with displacement S, and the force that is applied is 60 to this way and 20 to the left and 250 downwards. Calculate the total work done on an object that displaces a distance of 1.5 along a horizontal floor. So it displaces along a horizontal floor. So it's going to the right lah, to the right, due to the forces as shown. Okay, so I want you guys to try this one, but I will be apa nak kata, pecahkan kepada beberapa forces lah. So work done, we can write it like this. Work done number 1, F1 dot S. Okay, force number 1, let's say this is force number 1 dot S. Okay, work done number 2, F2 dot S. Let's say this is F2 vector. This is F3. The work done 3, F3 vector dot S. Okay. So as you can see here, I'm writing work done number 1, work done number 2, work done number 3 with respect to each forces. Nanti at the end, because this is a scalar quantity, we can just simply add it. So work done net is equal to work 1 plus work 2 plus work done 3. This will give me the final answer. So force 1 is 60 newtons and the angle is 30. What should I write here for work done number 1? Kita tahu kalau work done and it's a dot product, we have to expand it, right? F1 as cosine theta. So what are the values over here?
60.
60. What is S?
1.5
1.5
Right?
cos
What
cos
is
30.
30? Okay. And what about number 2? Work done number 2. Sorry, number 2. Okay.
20
20.
1.5
1.5.
cos
0. Huh? Cos?
cos
Okay, so the cost, the
150.
angle here is confusing. Apa? 180?
150
150. Okay, so someone tried 150. Let's see, nanti kita tengok betul ke tak. Don't worry about it. Kalau salah tak apa, we are learning here. Okay, what about work done number 3? This is number 3. So it's 250.
250.
Mhm.
1.5.
1.5. What about the angle?
240.
240. Okay, that's right. Okay. So your friends answered this way for work done. Kita akan tengok macam mana nak define the angle. So remember the dot product of two vectors, the angle in the equation is associated to the angle between the vectors, not associated to the x-axis, not associated to the y-axis. It's the angle between them. Kalau ada vector A dan B, this is the angle that we're looking for. Okay, so in this case, we are looking between force and displacement. So kita ada force number 1 and the displacement, it says that it is 1.5 along a horizontal floor due to the forces as shown. This is the starting point of the box and this is the end point. So this is my vector S. Okay, so this is my vector S. Okay, so let's see, work done number 1, 60. 60, that is the magnitude of force number 1. 1.5, that is the magnitude of S vector or the displacement vector, cosine 30. So let's see, force 1 and the displacement is 30 degrees. So it looks good, right? Macam betul je, saya rasa betul. So work done number 2 is 20, 1.5. We're not, at this point kita tak kisah pasal direction dia sebab kita nak tahu magnitude je. F dengan S ni magnitude. Yang penting kat sini is angle. So some of you said 150. Do you want to revise or do you think this is correct? Anyone wants to revise? Anyone is saying this is correct? What is the angle between these two vectors?
180
180. Sebab kita tengah cakap pasal S dengan F2. Kita tengah cakap pasal F2 dengan S, not F1 and F2. Kalau F1 dengan F2, yes, it would be 150. But now, The equation is F2 with S. So the angle is 180. Okay, so this becomes 180. But good try. It shows me that you are thinking about F1 and F2, which is nice as well. Okay, so work done number 3. Now, what is the angle between them?
270.
270. So we are talking about this angle. Okay, so it's 270. Okay, so now I use my calculator. So far everyone okay? Boleh faham ke setakat ni?
Boleh.
Soalan? Any questions that is making you confused? Need to tell me. Saya kecilkan jap. Cuba tempat. Group this. Kecilkan. Okay, so let's write the answer. Can anyone calculate this for me? This one and this one, please. What do you guys get?
77.94.
77.94. Is it positive or negative?
Positive.
Positive. Okay. The second one, please.
Negative
Negative 30.
Negative 20. Okay.
30.
Which one?
30.
Oh, 30. Okay. The third one, please. 30. Betul lah.
0.
0.
Okay, so now that we've got the answer for, thank you everyone. So now that we got the answer for work done number 1, work done number 2, and work done number 3, let's take a look at the signs. So kita tengok sini, this is a positive. Let's look at it. F1 is going this way and F and S is going this way. So F1 akan ada component to the right, which is overlapping with S. So that is why the answer is positive. So, but when we talk about F2 and S, F2 is going the opposite way of S. This is S and this is F2. So F2, dia ada komponen dalam sama axis dengan S, tapi terbalik. So this is why you get the negative sign. It is in the same axis, but it is in the opposite direction. That is why you have the negative sign. For F3, it's going this way. Can anyone tell me why it's a 0?
90 degrees.
Because it's 90 degrees, it's perpendicular, which means that there is no component in this axis. F3, dia tak ada komponen dalam S. Kalau kita cakap ni, FY, ni FX. FX and FY cannot mix, right? FX and FY cannot mix. If I have a component that is FY, I cannot resolve it into X. It is just Y because they are 90 degrees. So apa-apa yang 90 degrees memang akan dapat kosong. I mean, you won't have a component in the other axis lah. So when we are talking about F3, in terms of S, it's a 0 because it's 90 degrees. Okay, so in this case, you can also say the angle is 90 because we are just talking about the angle between them. So it can be this way, it can also be this way. So dua-dua boleh dapat jawapan yang sama. Okay, so this becomes a 0. Okay, so the final answer is work done net. I can write it like this, or I can write it like this. Means the same thing. Work done net or net work done, sama je. That's the math symbol. So work done net is W1, W2, W3. Scalar quantities only have magnitude, so I can just add them together. I don't have to worry about the direction. I don't have to resolve sebab dia scalar, dia magnitude sahaja. So 77.94 minus 30 plus 0. So that is your final answer. Kira pakai calculator lah, dapatlah jawapan dia. Okay, so that is how you use the dot product. Okay, so this is the cross product. Do I have any question? Okay, tak ada. This is the cross product like I mentioned to you before. The final answer of a cross product is a vector that is totally perpendicular to both vectors. A final vector that is perpendicular to both vectors. Okay, dia akan perpendicular to V, dia akan perpendicular to B. Tu final answer dia. The force is perpendicular to V and also B. So let's take a look at this. We're not talking about F yet. B is to, let's take a look at this guy over here. Tengok kat sini Orang lain tak payah tengok. Tengok kat sini je. Terbesarkan. So my V is going this way and my B is going into the page. This is the sign X. Into the page. So what does into the page mean? Oh, saya tinggal 10 minit je. I'll make this quick. What does into the page mean? Okay. Oh, comaknya muka saya. Okay, so can you guys look at this book? Tak boleh. Macam mana? Sekejap Macam nak bagi nampak? Hello. Tak boleh nampak. Kejap I'm going to remove my background. Tak boleh tunjuk. I don't know how to do it. Need to stop sharing for a second. Zoom meeting. Background preferences. Background filter, none. Okay. Okay, so let's take a look at my book here. Okay, so when I say into the page, look at my pen here. My pen ada dia punya mata pen kan? This is mata pen, this is buntut pen. Sorry, butt of the pen. So this is my page. When I say into the page, my mata pen is going into the page like this. It's like that, into the page. So when I say into the page, it's like this. When I say out of the page, it is going like this. Out of the page. Keluar dari muka surat. Keluar dari muka surat. Masuk dalam muka surat. Into the page. Out of the page. Okay, so let's go back to the example. Share screen. So when I put this X symbol, it means into the page. Kenapa? Sebab look at an arrow. Okay. This is my arrow. Okay. Anak panah yang biasa orang duk pakai busa tu. Busa? I don't know what it's called. So this is my arrow and this is my paper. Dia into the page. This is my eye. This is your eye because my eyes are beautiful. Ni buruk kan? So korang punya mata lah. So mata korang tengok apa? Bila korang tengok pada situ kan? You guys are looking at the butt of an arrow. So this is why you see the X. That is the symbol X. However, if your arrow is out of the page, your mata is here, right? This is your eyebrows. This is your eyes. What are you looking at? You're looking at mata anak panah tu kan? Mata anak panah. Mata korang nak tercucuk. So what are you seeing? You are seeing a dot. Sebab dia up close kan? Nampak mata, nampak bulat je lah, nampak dot. You're seeing the tip of an arrow. So that when you see the tip of an arrow, dia punya symbol dot. Dia akan jadi macam ni, dot, dot, dot. So you know that the B is out of the page. Okay, so itu pengenalan kepada into and out of the page. So here, you are using the X. I mean, the example is using X, which means that the B is going into the page. So ni page kan, yang ni kertas. Ni kertas kan. So pen korang masuk dalam page. So B adalah ke dalam page. So B macam tu lah rupa dia. Macam mana saya nak lukis? Tak tahu. Let's draw into the page macam ni lah. Kita buat gambar lain lah. So this is my V. Into the page. Macam ni lah. Okay. So this is your B. Okay. So V and B with the cross product, kita akan expand dia to become Q is a scalar. Q, V, B, sine theta. What is the angle between them? Something, whatever, 50 degrees boleh. So this becomes VB sine 50. So this resolves my B to become perpendicular to V. So dia akan jadi perpendicular to B. So B sine theta something akan dapat, ya Allah salah ni. 50 degrees bukan macam ni, lupa dia. 50 degrees patutnya kurang daripada 90. So this is B. V and B. So when I use this equation, I am resolving B to be perpendicular to V, right? I'm resolving B to be perpendicular to V. And what is the final answer? The final answer is force. I want to know what is the direction. This equation gives me the magnitude. I want the direction now. So the direction of force is perpendicular to V, is perpendicular to B, and the answer is down here. Okay, so dia 90 degrees dengan B. Sorry, dia 90 degrees dengan V, dia 90 degrees dengan B as well, B sin theta. Okay, so as you can see here, dia nak macam, so kat sini susah nak tengok lah sebab dia 2D kan. Tapi jawapan cross product selalu memang wajib 90 degrees to both vectors. Okay, so don't panic about this one. What is the takeaway from this subtopic is that you have to know dot product akan dapat scalar in the same axis, cross product akan dapat magnitude by multiplying both vectors with sine theta, and the direction is always perpendicular to both vectors. This is what you need to know. Okay, kena hafal ke equation ni? Tak payah. This is just an example. Okay, so that is it for today. Tak sempat masuk chapter 2. It's okay. I'll see you tomorrow. And have a great lunch. Have a great rest of the day. Okay, so take care. Bye, everyone.
Thank you, Doctor.
Thank you,
Welcome.
Doctor.
Thank you, Doctor.